Good day everyone! Welcome to another session of Mommy Teo Teaches Math. Our topic for today is illustrating ordinary simple annuity and simple annuity due. But before that, let us try to classify first these annuities. There are three classifications of annuity. The first one is ordinary annuity. It is an annuity whose payments are made at the end of each payment interval. Take note of this, end of each payment interval. Annuity due is an annuity whose payments are made at the beginning of each payment interval. Take note, this one is end and this one is beginning. When we say ordinary, that's ending. When we say annuity due, that is beginning. Okay. And the third one is deferred annuity. It is an annuity whose first payment will start at some future date. For ordinary simple annuity, we have two formulas. FV equals R multiplied by quantity 1 plus I raised to n minus 1 divided by I, where FV is the future value and R is the periodic payment. PV is equivalent to R multiplied by 1 minus quantity 1 plus I raised to negative n divided by I, where PV is the present value and R is still the periodic payment. How are we going to get the n? The n is equal to MT. What is M? M is the compounding period. M is the compounding period. So if it is annually, 1. If it is semi-annually, 2. If it is quarterly, 4. If it is monthly, it's 12. And then T is of course the time in years. And then how are we going to solve for I? I is equivalent to rate of interest divided by the M. Again, this one is the rate of interest, the one that has percent. And then what else? So, no more. I is already here. R is the periodic payment and is solved by multiplying M by T. Let's take example number 1. Money is worth 8% compounded quarterly. What is the present value on annuity paying 1,000 quarterly for 15 years? Take note that this one is quarterly and quarterly. That's why it falls under simple annuity. Now, why is it ordinary? Because if it is not stated in the problem, ending or beginning, meaning to say it is understood that it is at the end. And that is, of course, for ordinary annuity. Okay, let's solve this example by identifying first the given. We have the R, the periodic payment, and that is how much? 1,000. We also have the T, that is 15 years. We also have the R, that is 8%. We also have, of course, the I, which is equivalent to R divided by M. Our M is compounded quarterly. So that is compounded quarterly, that is 4. Okay. So our I now is equal to 0.08. This one, you move the decimal point 2 places to the left. That will be 0.08 divided by 4. So I is equal to 0.02. You can also solve for the N. That is M times T. M is 4 and T is 15. So this one is 60. So since we are looking for the present value, we will be using this formula. PV is equal to R multiplied by 1 minus quantity 1 plus I raised to negative n divided by I. So, substituting this here, this is 1,000 multiplied by 1 minus 1 plus 0.02 raised to negative 60. Okay, so this is negative 60 divided by 0.02. So PV is equivalent to, how are you going to do this in your calculator, scientific calculator? You just press 1 minus 1.02 raised to negative 60 equals divided by 0.02 and multiply it by 1,000. And you will be getting there 34,760.89. That is the present value. Example number 2. The buyer of a lot paid 20,000 down payment and agreed to pay 15,000 at the end of each 3 months for 5 years. If the payment is worth 6% compounded quarterly, how much is the equivalent cash price of the lot? Again, this one is a simple annuity. Why? 3 months quarterly. So they are the same, or they are equivalent. Now, what about this one? It says here at the end of each 3 months. So therefore, this is an ordinary simple annuity. So we are looking for the cash price. So we will be adding the down payment. The down payment is equivalent to 20,000 pesos. We will be adding it to the present value later. So our R is 15,000, our periodic payment. Our T is 5 years. Our R is 6%. So this is equivalent to 0.06. And then our M is 4. That's quarterly. It's 4. And then our N is equal to MT. So this is 4 times 5. N is equivalent to 20. And then for our I, that is R divided by M. So I equals 0.06 divided by 4. I is equivalent to 0.015. Okay? It's complete now. We are ready to substitute this in the formula. So we have PV, or present value, equals R 1 minus 1 plus I raised to negative N divided by I. So we have R is 15,000 multiplied by 1 minus 1 plus 0.015 raised to, that is raised to negative 20 divided by, of course, 0.015. So just calculate this. 1 minus 1.015 raised to negative 20 equals, and then divided by 0.015 multiplied by 15,000. The present value is 257,529.18. So what is now the total cash price of the lot? We will be adding the down payment, which is 20,000. So you will be getting there 18,925,772. So this is the total cash price of the lot. 277,529.18. Example number 3. If interest is at the rate of 10% compounded semi-annually, what sum must be invested at the end of every 6 months to accumulate a fund of 200,000 at the end of 10 years. Let us verify whether it is really a simple annuity. Semi-annually, every 6 months, they are equal, they are the same. It's really simple. Next, let us verify whether it is ordinary. It says here, at the end of every 6 months. So that's why it is really an ordinary simple annuity. Let us identify now the given. This 200,000 is the future value. We are looking for the R, the periodic payment. Our R, rate of interest, is 10. Our M is 2, semi-annually. And then, our T is 10. We can now compute for the M, that is M times T. That will be 2 times 10, it's 20. Okay, and then the I, that is R, 0.10 divided by 2. So I is equal to 0.05. Okay, so let us now use the formula FV equals R multiplied by 1 plus I raised to N minus 1 divided by I. Okay. So FV is given, that is 200,000 equals, this one is unknown, this is 1 plus 0.05 raised to 20 minus 1. Okay, divided by 0.05. Okay? So how are we going to solve for R? You just divide both by this one. That is 1.05 raised to 20 minus 1 divided by 0.05. Okay. Divide this by 1.05 raised to 20 minus 1 divided by 0.05. This will be cancelled now. And your R here, how do you do this in your calculator? 200,000 divided by, open parenthesis, 1.05 raised to 20 minus 1 divided by 0.05 close. You will be getting there 6,048.52. So this one is the regular payment, the periodic payment. 6,048.50. Let us go now to simple annuity drew. We have two formulas, FV and PV. Still, FV is the future value and PV is the present value. R is the periodic payment, N is equal to MT, I is equal to R divided by M. Example 1. Mr. Pacquiao, a businessman, agrees to make equal payments at the beginning of each 6 months for 8 years to discharge a debt of 50,000 due now. If money is worth 8% compounded semi-annually, how much is the semi-annual payment? So, let us verify first whether this one is a simple annuity. This one is each 6 months, that is the payment interval. It is the same as the compounding interval, which is semi-annually. So, they are the same or they are equal. Therefore, it's really a simple annuity. Let us verify this time if it is an annuity due. It says here, payments at the beginning of each 6 months. So therefore, this is really an annuity due. Let us identify now the given. The given are 50,000. So that is the present value. We are looking for the R. That is the periodic payment. That is the semi-annual payment. And then we have the R, small r, the rate of interest, which is 8%. So this is 0.08. We have the M. The M is 2 semi-annually. We have the T. We have 8 years. We can now solve for the N. That is MT. So we have 2 times 8. N is equal to 16. And then I is equivalent to 0.08 divided by 2. So I is equivalent to 0.04. Okay. So let us now use the second formula. The second formula is PV equals R 1 plus I minus 1 plus I raised to n, negative n, plus 1 divided by I. Okay, here's the formula. So PV is 50,000, that is 50,000 equals R is the one that we are looking for, and then 1 plus 0.04 minus 1.04. I added already, raised to negative n, that is a negative 16 plus 1 divided by 0.04. Okay. So simplifying it, we have 50,000 equals R. This is 1.04 minus 1.04 raised to negative 15. Because negative 16 plus 1 is negative 15 divided by 0.04. How are we going to solve for the R? You just divide both by 1.04 minus 1.04 raised to negative 15 divided by 0.04. So this one is 1.04 minus 1.04 raised to negative 15 divided by 0.04. This will be cancelled. How do you solve this? How do you calculate this? You press 50,000 divided by 2 open parentheses, open, 1.04 minus 1.04 raised to negative 15, close, divided by 0.04, close, you will be getting there 4,125.96 pesos. That is the periodic payment. Example number 2. If money is worth 8% compounded quarterly, what is the future value of an annuity due paying 1,500 quarterly for a term of 3 years? So let us verify if this one is really a simple annuity. We have quarterly and then quarterly. Compounding period is equal to the payment interval. That's correct, or they are the same. Next, let us identify whether it is really an annuity due. It is already stated here an annuity due. So therefore, it is considered that the first payment is at the beginning. Okay? So let us now identify the given. We are looking for the future value. Given R is 1,500. T is 3 years. R is 8%, or that is 0.08. And then M is 4 quarterly. N is MT. So that will be 4 times 3. It's equal to 12. And then I is equal to 0.08. That is R divided by M. Divided by 4, that is 0.02. Okay. So, since future value, we will be using the first one. FV is equal to R, quantity, 1 plus I, raised to n minus 1 divided by I times 1 plus I. Okay. Okay. So this one is FV equivalent to 1,500 multiplied by 1 plus 0.02 raised to n, 12, minus 1 divided by 0.02. Multiply it by 1 plus 0.02. Okay. So, first, of course, you need to calculate this one. How? 1 plus 0.02 is 1.02 raised to 12 minus 1 divided by 0.02. Multiply it by 1.02. Okay. So, calculating this two, just press 1.02 raised to 12 minus 1 equals, divided by 0.02 equals, times 1.02, you will be getting there 113,680,33,152 and so on. Multiply it by 1,500 or 1,500. This is equivalent to 20,520.50. So that is the future value.